Hi, as a part of these lesson series on quadrilaterals, let us discuss a few properties on squares. If in any quadrilateral all sides and all angles are equal and they are equal to 90 degrees, then it is called as a square. In a square, AB is parallel to CD, AD is parallel to BC, and all sides are equal, that is AB is equal to BC is equal to CD is equal to DA, and each interior angle is equal to 90 degrees. In this case, when I say AB, this line AB is parallel to CD and AD is parallel to BC, and AB is equal to BC is equal to CD is equal to DA, and each angle or interior angle is equal to 90 degrees, which we represent in this form. The first important property over here is diagonals are equal. Now we can find two diagonals over here. The diagonal 1 I can call as BD and diagonal 2 as AC, and these two diagonals will always be equal in any square. The diagonals bisect each other at right angles. The first point he is talking about is diagonals bisecting each other. When I say diagonals are bisecting each other, implies the length of AE will be equal to length of EC. Similarly, length of BE is equal to length of ED, which tells us that diagonals bisect each other, and the angles involved, this angle, they are all equal to 90 degrees each. Now he says diagonals bisect the angles. Now the third property, we'll discuss third property. In this case I have a diagonal. As we discussed, we said we have two diagonals. Diagonal 1 is AC and diagonal 2 is BD. If I look at this diagonal BD, it is cutting this angle, that is angle ADC, into two equal parts, that is this angle will be equal to this angle. Fourth property, each interior angle of a square is 90 degrees. This we already discussed. Each diagonal divides the square into two congruent isosceles right angle triangles. Now let us look at two triangles. Triangle number 1 is I can identify, that is ABC is one triangle, and then ABD is also one triangle. These two triangles are right angle in nature and also are isosceles, and then they are also congruent. These are the properties. Now let us look at how do we find the area of a square. Now for a square, we know that all sides are equal, and now in this example I have taken the length of each side as S and diagonal as D. We know that the area of any polygon is base into height. Now if I apply that for this square, the base is DC for this diagram, and the height is BC. Therefore the area of this polygon has to be DC times BC. Therefore it is side times side, or it is equal to S square, because my DC is equal to S and B is also equal to S. The perimeter of any square is nothing but we travel along the edge. If I travel along starting from A, so AB plus BC plus DC plus DA will give us the area, the perimeter of the square. So in this case, because all are equal, it is 4 times the side, or it is equal to 4S. Now if I know the length of the diagonal, or if I want to find the length of the diagonal given the side, it is given by S root 2, or side times root 2. But now if I am given a diagonal and then I want to find the area of a square, because area of a square we know when side is given by S square. But whereas if I'm given this diagonal D, length of the diagonal D, and asked to find the area of a square, then for that I'll use one formula, that is half into D square. These are the few properties which we need to know and understand, and so that we can solve some problems based on these concepts. I would like you to revisit the content, read them, so that your concepts will be clear. Thank you.